Well, hey there, everybody. It's your boy, Mr. Perry, and here we are finishing off Unit 4 with Lesson 5, Code Tracing Loops. So to be honest, there really aren't a lot of notes to take on this one. This one's really just going to be a lot of demonstrations on how to approach various loop questions and how to trace them out, but it is going to include a couple of important, key details, things to take note of, things that'll maybe give you some good shortcuts to work with when you're approaching these kind of problems. So we'll just do a quick review. All loops in Java need what three things? Go ahead and pause the video and see if you can remember what those three things are. I'm assuming you paused that video. Let's remember what they are. First off, they need to have a starting point. They need to have an ending point. And of course, they need a way to move forward. So those are the three things that all loops in Java need. And when it comes to code tracing, we also have 3 steps that we always follow. So feel free to pause that video, see if you can remember those 3 steps. But I'm going to go ahead and review them with you now. So to do code tracing, the very first thing that you do is read the question and figure out what's being asked. That's one of the most important things, is just make sure you know what the question is and what it's asking you to do. Then you go through, you count your variables, and you create your trace table. And then finally, the only way to do them is to trace that code line by line, one at a time, from top to bottom until you're done, and then you can answer that question. All right, so we're going to go ahead and try 3 practice problems here. All right, and so here we go. What are the values of variable 1 and variable 2 when the code finishes executing? And here is our code. So this one's going to be relatively low-key, low stress, not too tough. However, this condition right here looks a little bit intimidating, right? So there's maybe something going on here that's going to mess us up, but we'll see. Anyways, read the question and figure out what's being asked. We need to know what are the variables. What are the values of variable 1 and variable 2. So that's pretty straightforward. All right, count your variables and create a trace table. Well, I only see int var1 and int var2. I don't see any other variables, so those are the only 2 that we need to watch out for. Now let's go ahead and trace that code line by line from top to bottom. So let's start with this one right here. Int var1 equals 0. So we're declaring a variable of type integer, and we are instantiating it at 0. And then int var2 equals 2. So we're declaring a variable called var2 of the type int, and we're instantiating it with a value of 2. Now, the next line. Okay, while var2, so var2 is 2. So while 2 is not equal to 0, all right, well, that's going to evaluate to true. And var1 divided by var2. So 0 divided by 2, that's just going to give us 0. So as long as 0 is less than or greater than or equal to 0, all right, so that's going to give us true and true. So we've got both of those are true. And so that will work. And so we then go into here, and var1 equals var1 plus 1. So we just add 1 to that. And then down here, var2 equals var2 minus 1. So we subtract 1 from that. And now we go back into it and we check our condition again. All right, so 1 is not equal to 0. That is true. And then 1 divided by 1 is 0, and 0 is greater than or equal to 0. So I'm sorry, 1 divided by 1 is 1, which is greater than or equal to 0. So that is true. So we've got true and true. So that means we do our loop again. We add 1 to var1. We subtract 1 from var2. Now we go back into our while loop. And it says while 0 is not equal to 0, because var2 is now 0. Well, that means this is false. So boom, right off the bat, we know that we're done with this loop, and we can go ahead and hop out of it. And of course, when we hop out of it, we've got our answer. var1 is equal to 2. var2 is equal to 0. Bing, bang, boom, we're done. All right. Well, now let's see what happens if we combine a while loop with a for loop. And let's go ahead and work with some nesting here. So how many times is the string hi printed as a result of executing the code segment? All right, again, looking at our process here. Oh, by the way, what we are doing is what's called runtime analysis. This is a term, a vocab term that could appear on your AP exam. Runtime analysis is just basically counting the number of times a loop will run by checking its execution statement, and basically, just kind of counting it through. And Sometimes we might have nested loops, and if we have nested loops, again, we're just basically counting how many times is this loop going to run, how many times is that loop going to run. This is what's called runtime analysis. Anyways, we read through our question and figure out what's being asked. Again, we just need to know how many times high is going to be printed. All right, let's count our variables. We've got I controlling the while loop. We've got J controlling the for loop. So we've got I and J that will have our trace tables for. Now it's time to trace that code line by line from top to bottom. So here we go. Int I equals 0. So we've got 0 in here for I. And then we're going to do this while loop as long as I is less than or equal to 4. Obviously, 0 is less than or equal to 4 will evaluate to true. So that means we're going to hop into our loop. Now we're instantiating J to be 0, and as long as J is less than 3, we're going to go ahead and do what's inside. So we're going to print high, and let's see, J right now is 0, and now J is going to go up to 1. 1 is still less than 3, so we're going to print high again. J is going to go up to 2, and 2 is still less than 3, so we're going to print high again. J now goes up to 3, and 3 is no longer less than 3, or J is no longer less than 3. So that means we are done with our for loop. We hop down here to our I for our while loop, and we increment that. I is now 1, and we start it over. All right, so 1 is definitely less than or equal to 4. That is true. So we go back into our for loop. Now, we already know this for loop prints high 3 times. So we just know, okay, there's another 3 times. Increment our I again. I is now 2. 2 is still less than or equal to 4. So now we're going to do another 3 highs because we know the for loop prints 3 times. Increment our I again. 3 is still less than or equal to 4. So we're going to print high another 3 times. I goes up to 4. 4 is still less than or equal to 4. So again, that evaluates to true. We do another 3 highs, and now I gets to 5. 5 is not less than or equal to 4. This evaluates to false. That means we are done. And so if we count them up, that's 15 times. However, this program, this little algorithm, showed us a couple of things that we should probably take note of. There's a couple of patterns that we can see emerging from this one. First off, there's a shortcut. There's a little equation that you can use if you want to figure out how many times a loop is going to run. And that equation is take the largest value, subtract the smallest value, and then add 1 to it. Now, if the loop uses the counter variable is less than or equal to the limit, then that means the limit, whatever number's right here, is the largest value. That's what you would put here. However, if the loop uses counter is less than the limit, and it doesn't include the equal sign, that means limit minus 1 is going to be your largest value. So for this one right here, to look at the while loop, the while loop runs 5 times because I is less than or equal to 4 means that largest value is going to be 4. And then, of course, 0 is the smallest value of I. So 4 minus 0 plus 1 is 5. So you can just look at those two things and you can understand, all right, everything in this while loop is going to execute 5 times. Now, the next one is our for loop. Now, the for loop runs 3 times because J is less than 3 means 2 is the largest value. Because remember, if it doesn't have the equal sign, then you subtract 1 from that number. So 2 is the largest value. And once again, 0 is the smallest value. So 2 minus 0 plus 1 equals 3. So we know that the while loop is going to iterate 5 times. We know that the for loop is going to iterate 3 times. And the other pattern that we should take note of is that the number of times a nested loop body is going to execute, that equals the outer loop number of runs multiplied by the inner loop number of runs. So we could have just recognized, okay, this is a while loop that's going to iterate 5 times. This is a for loop that's going to iterate 3 times. This for loop is nested inside of that while loop. So you can just do 3 times 5 or 5 times 3, and that will give you 15. So these are shortcuts that we could have used as opposed to tracing out that entire algorithm. So there are a couple of shortcuts that are nice to know, and you definitely want to take note of those. However, sometimes it's more complicated. So for example, on this one here, the inner loop control variable J is initially set to the value of the outer loop control variable I. So what that means is there's no clear like low or high value with this one. Out here for int I equals 0, as long as I is less than or equal to 5, you know that this one is going to increment 6 times because it's going to start at 0 and go all the way up to 5. But we don't know how that's going to impact our inner one. Our inner one here is set up very differently. So the only strategy that we have here is doing our trace table. Now the question here is what will print as a result of executing this algorithm. So let's go ahead and figure it out. So here you can see our inner for loop for int j equals I. So again, that means that just kind of reemphasizes that this for loop is a non-traditional for loop, and we're going to have to trace this one out. So again, what's being asked here? What will print? All right, easy enough. Next, we got to count your variables and create that trace table. We've got I, we've got j, we've got our trace table. Then we got to trace that code line by line, top to bottom. So let's do it. For int I equals 0. So we're going to go ahead and do that. And as long as I is less than or equal to 5, let's go ahead and do what's inside. So we're going to print our asterisk. Now we're going to get to our inner for loop. Now this says for int j equals I. Well, right now I is 0, so that means j is going to be 0. And it says as long as j is greater than or equal to 0, go ahead and do what's on the inside here. So since this evaluates to true currently, we're going to go ahead and print that hashtag. And now we have to do j minus minus. So j goes down to -1. And -1 is not greater than or equal to 0. So that means this for loop is done. So now we hit our print line statement. So now we're bumping down to the next line and we start over at the top. I goes up to 1. 1 is still less than or equal to 5. So we go ahead and print our asterisk. Now we get into here, and now j needs to be set to 1 because, currently I is 1, so now we got to set j to be 1. 1 is greater than or equal to 0, so that's true. So we're going to go ahead and print that hashtag. Now we subtract 1 from j, so j goes down to 0. 0 is less than or equal, or greater than or equal to 0, so that's true. That means we got to print another hashtag. J goes down again. We're at -1. Which means this for loop is done. -1 is not greater than or equal to 0. So now we get to our print line statement. We bump down to our next one. And I think I'm starting to notice a pattern here, but let's go ahead and do one more iteration. Let's take I up to 2. And 2 is definitely less than or equal to 5. So we'll print our asterisk. Now let's set j to be 2 because j needs to be I. And, 2 is definitely greater than or equal to 0, so that's going to evaluate to true. So we will print our hashtag. J is going to go down to 1. We know that this is still true, so we're printing a hashtag. J goes down to 0. This is still true, so we print that hashtag. J goes down to -1, and once we get to -1, we know that we are done with this for loop, so we hit our print line statement. Now at this point, I'm just starting to notice a few things. I'm noticing that every time this prints, I get an asterisk and then an extra hashtag. So I'm noticing this pattern. So now I can basically just stop and say, all right, well, I know that my outer for loop is going to iterate 6 times. So I can stop with my trace table. I see my pattern. I know there's going to be 6 lines. They're all going to start with a asterisk, and each one's going to have an extra hashtag. So there you go. All right, lesson review. A trace table can be used to keep track of the variables and their values throughout each iteration of a loop. We can determine the number of times a code segment will execute with a statement execution count. This is called runtime analysis. The number of times a loop executes can be calculated by the largest value minus the smallest value plus 1, where these are the largest and smallest values of the loop counter variable possible in the body of a loop. And then finally, the number of times a nested for loop runs is the number of times the outer loop runs multiplied by the number of times the inner loop runs. All right, guys, thanks for watching. Plenty more practice to come in class. Don't forget to leave a question or a comment. I'll see you then.